Okay, this is our last video for Unit 2 on absolute value functions. So this is a flipped video, meaning I'm asking that you guys watch this outside of class and before coming to class next time. It's pretty short though. This is pretty short video. I'll try to not linger too long, all right? So in this video, we're going to talk about nested absolute value equations. And the word nested, the word nested just means you place it inside other things, right? So I like to think of these Russian dolls, right? One is nested inside the other, right? They all stack within each other. And so what we're talking about is a nested absolute value equation, which means absolute value inside absolute value. And so you could see an example right there. Now, there's not a whole lot new here. And in fact, you might be able to figure out this yourself. But I wanted to make a video on it to make sure it's clear how you're supposed to do these. So to solve an nested absolute value equation, I'm only doing one example in this video. You work from the outside in, and that's going to involve multiple cases that you have to work through. Now, the general premise is still the same. You still need to isolate. That's still going to be your first step, is isolating the absolute value expression. But what your goal is to first isolate the outer expression. So you're going to have an outer and then an inner, right? So you want to isolate the outer expression first, and then you'll create two cases. From there, you're going to isolate again, and then you're going to create two more cases. And so that's how this is going to split off. So step one, we're going to do this. Let's do it in blue. I'm kind of tired of red. Step one, we're going to isolate the outer absolute value. Okay, so you see that there's a 3 out there, right? I have 3 times absolute value 4 minus absolute value x plus 2 equals 3. I'm going to divide both sides by 3. And so that this is going to give me, I'm going to put this maybe in the center here, because I'm going to need some space. We're going to do absolute value 4 minus the value of x plus 2 equals 3 divided by 3 is 1. Now that you've isolated this is going to create two cases. So I'm going to do I'm doing sort of legs like this right now, just because a t-chart would get really messy. So we're going to do the positive case as normal, and then we'll also do the negative case. So the positive case is I just drop the bars, right? I do 4 minus absolute value x plus 2 equals 1. And the negative case, careful here, right? You have to think about this carefully. You're doing absolute value 4 minus x plus 2, right? The first case is you just keep it as it is. But the second case, you flip the signs, right? It's negative this. And so you have to distribute that negative to both pieces. So you're going to get negative 4 plus that absolute value. So the negative case is negative 4 plus absolute value x plus 2 equals 1. Now here, step 2, right? So this was step 2, two cases. Now step 3 is isolate again. So the thing is now you have two cases with absolute value. This is, now that you've done this, you're pretty much back to normal. This is just like solve, right? If I just handed you this, you would do the same old process. So that's all that's different. I could basically end the video here. You start with the outer, you do this, you create your two cases, and then now it's two separate absolute value problems to solve. But I'll go ahead and help out, right? We'll subtract 4 from both sides here. And so we get negative absolute value x plus 2 equals negative 3. We'll divide by a negative 1. So that way we get absolute value x plus 2 equals, let's see, negative 3 divided by negative 1 is positive 3, like so. Okay, we'll do it over here as well. Well, this one's much easier. We just add 4. So I just add 4 to both sides. That's going to tell us that x plus 2 equals 1 plus 4 is 5. And now that you've isolated these, you can make your t-charts, right? I mean, if you want to just do the legs again, you can, but positive case, negative case. X plus 2 equals 3, and negative x minus 2 equals 3. I'll quickly solve these. Minus 2, so x equals 1. Here I'll add 2, so negative x equals 5. That means divide by negative. Positive x equals negative 5. Over here, I do the same idea. I create a little bar like this, drop this down, a positive case and a negative case. So I do x plus 2 equals 5, and then I do negative x minus 2 equals 5. So minus 2, I get x equals 3. Here I'll add 2 to both sides, get negative x equals 7, divide by a negative 1, and I get x equals negative 7. And those are my 4 answers, right? But what do I need to do? I got to check, right? So step 4, so what I've done here, right? I guess step 4 was 2 cases and solve, right? So that means the 5th step here is to check for extraneous. And remember, to check for extraneous, we just plug in all our answers. So we have to go, this is important, this is why I go through the entire video. You have to test the one you started with. If you test this and this, well, of course it's going to work. That's what you solved. You need to test the original, the OG, right? So absolute value 4 minus x plus 2 equals 1. That's what we're testing. So we'll test, right, 4 answers. X equals 1. Well, that's 4 minus, this is 1 plus 2 inside these bars. Does this equal 1? Right? Well, that's 4 minus 1 plus 2 is 3. And so that's 4 minus 3, which equals 1. True. That one works. Okay? Here, I'm going to lasso that. I'm going to put this right here. So x equals 1 works. Now we'll try negative 5. So x equals negative 5. We'll do 4 minus negative 5 plus 2. Does this equal 1? Well, that's 4 minus negative 5 plus 2. That's negative 3. Does that equal 1? Well, that's 4 minus positive 3 again. That equals 1. Yes. So negative 5 does indeed work. Okay, I'm going to have to keep moving these because I'm going to run out of space. Let's move this guy here. And now we'll test x equals 3. X equals 3. If I do 4 minus, now it's 3 plus 2. Does that equal 1? Well, that's 4 minus 3 plus 2 is 5. And if you think, okay, well, 4 minus absolute value 5, that's negative 1, which equals 1. Yes. So 3 does work. And then finally, you have to test negative 7. I'll just test it here, and I'll move it later. X equals negative 7. We do 4 minus negative 7 plus 2 equals 1. We're trying to verify. That's 4 minus, this will be negative 5. And then, of course, the absolute value of, right, that's minus 5, right? So it's minus positive 5. That equals the absolute value of negative 1, which equals 1, which means it works. So all 4 answers work. All 4 answers are good. Therefore, we're good. I'll just write, therefore, the solution said is x equals 1, 3, negative 5, and negative 7. You don't have to put them in order or anything. Just put the numbers. The order doesn't matter. And that's it. That's the video. So, yeah. This is an example where all 4 solutions work. That's not always the case. That's not always the case. So, careful. Yeah? Do check for that check does matter. You may find only 2 of them work. You may find only 1 of them work. You may find that 3 of them work. You may find that none of them work. And you do need to check for extraneous. Okay? But that's it. It's really just still solving. It's nothing totally new, but yeah, you just want to be careful. So, alrighty, that's it, and see ya.